So this lecture is about the medical imaging informatics. So our learning objectives today are to outline the field of medical imaging informatics, describe the history behind digital radiology and the creation of picture archiving and communication systems, PACS, describe the difference between computed and digital radiology, itemize the benefits of digital radiology to clinicians, patients, and hospitals, and describe the new imaging technologies such as web PACS and mobile imaging viewers. And finally, we will list the challenges facing the adoption of picture archiving and communication systems. So, medical imaging informatics can be defined as the study and application of processes of information and communications technology for the acquisition, manipulation, analysis, and distribution of medical image data. And this is a definition from the Society for Imaging Informatics in Medicine. So it studies every aspect of imaging, the acquisition اللي هي أخذ الصور، storage تخزين الصور، interpretation and manipulation اللي هي معالجة الصور وتحليلها، and sharing the picture to improve the patient care. And this field tends to include the radiologist and also the scientists who are involved with medical physics. The imaging informatician must understand how imaging data moves throughout the medical organization and how it interacts with the electronic health records, voice recognition, dictation systems, computer-aided diagnosis software, and health information organizations. And also the specialist in the field must have a good understanding of the workflow, the networks, the security, the data quality, the hardware, and the software, similar to the skills set needed for the electronic health records. And the supporting group for the field is the Society for Imaging Informatics in Medicine. So picture archiving and communication systems, the PACS, is the medical imaging technology which provides economical storage of and convenient access to images from multiple modalities. فالباكس system الباكس اللي هو عبارة عن نظام يمكن الشخص أو اليوزر من تخزين الصور الطبية والوصول السريع للصور الطبية وكمان أخذ الصور الطبية من أجهزة أشعة مختلفة. So we have digital imaging modalities in health اللي هي عبارة عن أجهزة للتصوير الرقمي الطبي. We have computed radiography, and we have digital radiography, and we have computed tomography and magnetic resonance imaging, MRI, and we have the ultrasound and also other modalities to take digital imaging. The history of digital medical imaging started in the 1970s. So the medical imaging has progressed along with similar to the photography. there has a gradual shift from analog images, which are printed on films, to digital images that are captured and saved on electronic media. Um, and this transformation has occurred slowly uh, over the time and has been possible as a result of the development of technology, of image sharing technology and transmission. So the first filmless hospital occurred in 1999. As we said, the development or the transitioning to the digital medical imaging was facilitated by first we have the development of digital imaging technology. So we have different modalities, digital modalities now. There are the computed tomography, ultrasound, and the magnetic resonance imaging, which was developed um, in the 1970s and 80s. These modalities they resulted in digital images which can be displayed on monitors at uh, 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 specialized workstations attached to the device, and the images can be printed onto films, and also uh, uh, in addition to saving them electronically. So the conventional the scanning conventional radiography, the X-rays, which use a film scanner, uh, also can be transformed to be digital. But here the computed radiography and digital radiography become available, and this eliminate the need for um, film processing and storage room, and also the images can be viewed at a remote location because we can send the images over the networks, and this will lower the cost. The third reason is we have the computer-based image archiving uh, was necessary because we need to um, have a system that can store and uh, help in accessing uh, the uh, the images in faster, uh, and that can be happen by using a computer-based image archiving. So to shift to the digital imaging, hospital used film scanner or other digital imaging technology to produce images that can be stored and viewed in computer. These equipment or these devices were proprietary uh, uh, equipment and imaging formats, which are a file format created by a specific company which produce this equipment, and it was owned by the company. كان في مثل الحقوق لنوع الأفلام. ف كل شركة مصنعة لأجهزة التصوير أشعة رقمية كان لها نوع ملفات معين. ما نقدر نستخدم الأشعة من شركة إكس ونعرضها على جهاز مصنوع من الشركة واي، لأن كل شركة تستخدم نوع معين من الفايل أو الفورمات يكون تحت ملكيتها. So when, as we say, the CTs can perform on one of the manufacturer equipment like X manufacturer, this CT cannot be viewed using Y manufacturer imaging workstation. The workstation and the acquiring devices need to be from the same manufacturer to allow the sharing and the displaying of the image. So we needed a standard that will facilitate the image sharing, the transmission and the viewing of the images on each equipment and in different equipments and products. So as a result, we have the DICOM. The DICOM is a shorten for the digital imaging and communication in medicine. So this is a standard, a universal standard or international standard, was created to facilitate the image sharing, the viewing, and transmission. So each equipment need to either produce or convert the image to DICOM format to be used on another equipment or another device. So it was developed by the National Electrical Manufacturers Association with the help of the American College of Radiology, and it provides a mechanism for storing, printing, and transmitting the digital image for information for medical images. And this standard enables the integration of imaging equipment and imaging archiving or storage archiving system and imaging workstations, printers, and network hardware from a variety and different manufacturers to be combined into one picture archiving and communication system. So we have one unique language or universal language. All the manufacturer equipment need to speak this DICOM or this language, the standard. So to make the PACS system function efficiently, we need a faster processor, higher capacity disk drivers to save the images and videos, a faster processor to process and manipulate the images and the videos, and higher resolution monitors, because usually the medical images and video are very detailed, has many detail, and based on these detail, medical decision will be taken. And we need better server to process also and save and back up these data, and faster network speeds to allow the faster transmission of the images between different locations. So to enhance the patient care also, and to enhance the radiology productivity and the workflow. It also we need to integrate the back system with other systems used at the hospital or the health organizations, such as hospital information systems, electronic medical records, and the radiology information system. So we have two types of radiography، which اللي هي أجهزة لأخذ الصور الأشعة الطبية. The first type is computed radiography (CR). So after the X-ray exposure to a special cassette, instead of films, so we don't need to use films now. We need to use this cassette where we'll save the picture, and the laser reader scan the images from the cassette and convert it to a digital image, which can be viewed digitally on a monitor. The image on the cassette will be erased to allow the cassette to be used repeatedly. So فيمسحون الإيمج من الصورة بعد الانتهاء من تخزين الصورة digitally، على أساس أن نقدر نستخدم الصورة أكثر من مرة، أو سوري نقدر نستخدم الكاسيت أكثر من مرة لأكثر من مريض. The second type of radiography, here we have digital radiography. Here we don't need the intermediate step of laser scanning. So through the receptor, the images will be taken from the patient, and it will be processed digitally without the need for a laser to scan it, and it will be saved and in the storage area through the use of the image management system, and through the network the radiologist can access and display the image using far away or remotely using the network, and also using a specific workstation. So digital imaging has many benefits. It replaces the standard X-ray film archive, and that means we need much smaller storage space, and also it reduces the need for file clerks who an employee who store the films and process the films, and also search for the films for the patient. It allows for remote viewing and reporting, which also include the teleradiology, as we discussed at the previous lecture. So it allows multiple clinicians to view the same image from different locations, and it also allows quicker reporting back to the requesting clinician. So anytime a clinician requested a report, the report can be done from remotely from home or far, and it can be uploaded to the cloud, and the clinician can view it as soon as possible. The digital imaging, it allows computer aided detection and this is a computer program that has been developed and approved for use in clinical practice that aid the radiologist in detecting potential abnormalities in diagnostic radiology exam. فهذا آه، عبارة عن برنامج يساعد أخصائي الأشعة في إنه يحدد أي آه، تغيرات غير طبيعية في صورة الأشعة للمساعدة في تشخيص المشكلة أو الحالة. It accelerate or expedites اللي هي the incorporation of medical images into electronic health record and another systems or other systems like the hospital information system and voice recognition systems and the computer aided detection and the images also can be archived and transported on portable media, for example USB driver and also Apple iPhone and or smartphones. So if you need a radiology image from the hospital, you can go to the medical record and ask for it, and they will provide you with a CD or a USB that has your image, and you can view it in with or you can consult on other physician or keep it uh, in your position. Fewer lost films, and this is as a result of not having any film to save the images. So since we don't have films, we will not lose them anymore, and we don't need anyone to search about them. The films or the images will be linked to the electronic medical record for the patient, and in this way it will not be lost. We have two types of picture archiving and communication system, PACS. We have full PACS and we have mini PACS. The full PACS, the images will be processed from many or different modalities such as ultrasonography which اللي هي أشعة فوق صوتية, magnetic resonance imaging اللي هي MRI, التصوير بالرنين المغناطيسي, pastron emission tomography اللي هو التصوير المقطعي البوزيتروني, and we have the computed tomography اللي هو CT اللي هو التصوير المقطعي, and we have the routine radiography اللي هو التصوير الإشعاعي, and endoscopy اللي هو المنظار الداخلي. فالفول باكس تكون الإيمجز ممكن تتعالج من أو تتم معالجة الصور من أجهزة مختلفة للأشعة. In the picture you can see this is the back system, and it can receive and process and share the images from different modalities and different workstations, and it can save and store the images also on disks or portable devices. So here we have, this is acquisition modality and this is another acquisition modalities, and all the images will be saved as DICOM or using the DICOM standard, and they can be shared and saved on portable devices. The mini PACS, on the other hand, is more limited and processes images from only one or two modalities. So it's very limited. It can manage and process the images from one or two modalities as maximum. An example is the cardiologist will use it to display only the echocardiography اللي هو تخطيط صدى القلب and cardiac catheterization images اللي هي القسطرة القلبية. فهذا الجهاز يعرض أشعة أو صور من نوعين من أجهزة الأشعة اللي هو الإيكوكارديوغرافي اللي هو تخطيط صدى القلب والصور القسطرة القلبية. So the PACS key component, the main components at the PACS, we have the data acquisition devices, the modalities اللي هي الأجهزة اللي تاخذ صور الأشعة وممكن تكون أجهزة مختلفة and the network okay the network ممكن تكون شبكة داخلية أو we can use the internet and the database server here the database server اللي هي السيرفر it will save the images and ties the PACS component and there is also the archival storage اللي هي نسوي فيها تخزين وأرشفة الصور لتسريع استرجاع الصور وكمان للحفظ لعمل اللي هي نسخ احتياطية من الصور لحفظ صور البيشنت أو بيانات البيشنت من التلف. And there is also the radiology information system and the workstation or soft copy display and also the teleradiology اللي هو workstation. طبعا الworkstation ممكن تكون inside أو ممكن تكون offsite اللي هي حتكون عن طريق التيلراديولوجي والانسايت اللي هو ممكن تكون عن طريق الراديولوجيست or physician he can view the image. So now we will explain each component in detail. First, we have the digital acquisition devices, the modalities, which are the sources of images. So they are devices and they produce the images or they are the sources of the images. Such as these are example of the modalities. We have digital angiography اللي هو تصوير رقمي للأوعية الدموية and we have the fluoroscopy اللي هو منظار صيني. عندنا الماموغرافي اللي هو التصوير الرقمي للثدي. we have the CT اللي هو التصوير المقطعي. ال MRI التصوير بالرنين المغناطيسي and ultrasound scanner اللي هو التصوير بالموجات فوق الصوتية. Then we have the network. The network it ties the PACS component together اللي هي تربط جميع مكونات الPACS. So it's the pathway for image transmission from the modalities or the digital devices to the PACS server or the image archive, then to the radiologist and the workstation, and it will move from and to also the network. It will be used to move from and to. So it will be internal network if the transmission was inside the organization, and it will use the internet in case of teleradiology. Then we have the database server or the PACS server. They will have a high speed and robust central computer to process the information, and it will answer all the requests or receive all the requests of the reading radiologist to provide the images to them and to the workstations also. The archival storage or server, uh, it's responsible for storing the DICOM images, and the server will enable the short-term, the fast retrieval, and also the long-term, the slower retrieval storage. And the HIPAA Act requires separate backup, usually off-site. So they need to make a backup off-site the organization اللي هي تكون خارجية بعيدة عن الorganization to prevent the data loss in a disaster situation. Then we have the Radiology Information System, the RIS. Uh, It's the system that maintains the patient demographics, the scheduling of the appointment, the billing information and interpretations. And also this system is linked to the modalities to request the exam for a patient, and also it can be linked to the back server to view the image and write the report and link it to the electronic medical record of the patient. Then we have the workstation or soft copy display. So this is a computer that contains the software and hardware to access the BACS server uh, and view the digital image in DICOM format. So it allows the radiologist to review the images, the imaging study, and dictate his diagnostic report, which will be linked to the electronic medical record through the radiology information system. The teleradiology is the ability to remotely view the images at a location distant from the site of the origin of the image. So the typical PACS workflow, first the patient is identified in the hospital information system. We know that this patient has a record at the hospital information system. Then the order will be created by the physician and sent to the radiology information system via the HL7 protocol اللي هو this protocol we talked about it earlier. It's a standard for exchanging and integration and sharing and retrieval of electronic health information. So it sent the order to the electronic medical record through this protocol. 3, the orders will go to the imaging device اللي هي acquisition modalities via the DICOM protocol, and the image is created in the DICOM format and sent to the back server. In the fourth step, the image will be stored on the image archive. The 5th step, the radiologist, who is the reading physician, will be notified that there is a pending study need his diagnostic report, and the study is then read by the radiologist at a computer workstation using high-resolution monitors and viewing software available from a variety of different vendors. And each modality will has its own software. The viewing software typically allow comparison of the present examination with any prior examinations for the patient to view any changes. The sixth step is when the uh, radiologist complete his detailed review of the images, a diagnostic report uh, will be generated by the radiologist, and often they use a voice recognition system, uh, which is a software that recognizes the voice of the radiologist, and the dictation is then will be reviewed and any corrections made if that was necessary. In the seventh step, the report will be stored on the back server and linked to the image. So each image has its linked with its report. And last, the report also will be sent back to the hospital information system via the HL7 protocol message, so it can be viewed as part of the medical the electronic medical record of the patient by the physician. So the bags face many challenges to be adopted by the health organization. Um, First, we have the cost, which is the greatest barrier. Uh, Even with the open source and rental packs uh, that can be alternatives, we have the expense and the complexity to integrate the packs with the hospital and radiology information system, and also the electronic health records. And there is a lack of interoperability with other packs, and the bandwidth limits may require network upgrades to allow the faster speed to share the images and videos, and different the workstations may require upgrade if the high resolution monitors are necessary. So if there is a need for higher resolution, we need to update and upgrade the workstations, and different vendors may use different DICOM tags to label the films. So there is not one tag that can be used, because each vendor will use different DICOM tags to label the films. And the last, the viewing digital images, they are a little slower than the routine X-ray films, because uh, the images file will be very large and need a very a very fast processor to manipulate the images. The most readily available means for rapidly and widely disseminating medical imaging is via the internet. So for faster sharing, we can use the internet and the World Wide Web to share the images, regardless of the location of the patient records, reports, and the images. Uh, Creating the packs that is accessible from internet would provide on-demand online access to electronic images from anywhere, reduce the need for duplicate studies in different hospitals. So if, for example, if you have done a radiology test on hospital X, and you need to um consult another patient in another physician at another hospital, uh, you don't need to duplicate the study, or you don't need to go to hospital Y and redo the or retake the radiology test again. You can share it. You can share the previous or the old study with the second hospital. So this will reduce the need for duplicate studies in different hospitals and allow more rapid diagnosis and treatment. So this will save the time and the effort and the money also. But it requires robust bandwidth, the maximum data transfer rate for the internet connection. So we need a fast internet connection for web-based PACS. The web-based PACS challenge, uh, uh, the main challenge for the web-based PACS is the DICOM imaging format, because the DICOM imaging format is not browser compatible. So you cannot view the DICOM images on your browser using like any image, like the JPEG, the GIF, and the PNG, and other file format or image format. So this is the main barrier for web-based PACS. And one of the solutions to this problem is the web-enabled PACS software. So there is for the browser to serve as a link to a server which can open and display the image and then stream it to the viewer. We need to have a client software on the viewing computer to allow this functionality. So we need to have a PACS vendor. We need the PACS vendors to develop uh, a software web enabled to their PACS and provide remote viewing. Uh, Usually, these need to download a small application from the PACS vendor on the remote viewing workstation to view and manipulate the image. So the drawback here is we need a frequent update for the client software mini application, and also due to the browser technology changes. The second solution is to use a zero footprint web viewer. So this is an alternative solution. Here we have a system that enables or a software that enables direct viewing in the browser without the need of installing and downloading a small application on the computer, uh, and with the internet functionality. Uh, so as we said earlier, the DICOM is not viewable uh, within the internet browser. So for the browser to display the images, they must first to be converted to an imaging format that is compatible to be displayed on the browser and then be opened by the browser. So here the DICOM images will be pre-converted. So first, when we need to convert the DICOM images to another image format, GIF, which is browser compatible, and then it will be embedded in a web page through in a link, and uh, zero installation will be needed. So we don't need to install any additional software. The advantages, as we said, not requiring additional software, and without requiring periodic updates. Also, uh, in addition, there is no maintenance need on the computer involved, and also no client software has been downloaded or requires maintenance. BACS advantages. So the digital image advantages, they are also part of the BACS advantages. So the BACS can be web-based and use service-oriented architecture, such that the image has its own URL link, and this will allow the sharing of and access of the image from multiple hospitals. Also, unlike the uh, conventional X-rays, the digital films here have a zoom feature where you can zoom in and zoom out the picture or the image, and it can be manipulated in innumerable ways, or various ways or different ways. Uh, it increased the productivity and the efficiency, uh, also by integrating the back system to the radiology information system and other systems workflow like the hospital information system and the voice recognition systems. And the rapid retrieval of digital images for interpretation and comparison with previous studies. This is another advantage. And the radiologist can view the image back and forth like a movie, which is known as a stack mode, to allow them to detect any changes over a period of time. Backs in mobile technology. So until 2011, the FDA prohibited any physician from using radiology images displayed on mobile devices to make any official diagnosis. So that decision was a result of that mobile phone were not clear as monitor at that time, so it will not be reliable to uh, take important medical decision. In February 2011, the FDA approved the first primary diagnostic radiology application for mobile devices. Examples of bugs in mobile technology. First, we have the mobile MIM. The mobile MIM, it includes a ViewMe version for patients. So the patient, they can have the ViewMe version to access the image. The viewer software is free, but there is a charge if you want to store and view the image on the company server. The second example is the Ozarix mobile DICOM viewer. This is a free and open source DICOM viewer that connected to BACS for Mac operating system. So you can use it and install it on Mac desktop, laptops, and iPhones or iPads. So BACS in mobile technology have drawbacks. The screen are smaller compared to the workstation monitors, and also the users are not able to dictate reports or view comparison films side by side. On the upside, there are features on the mobile devices that place these devices on the same level or above the different packs. For example, we have the user experience. So navigating the iPad and Android tablet will be easy because they will be similar. And the application will be developed on a native graphical user interface. So now the developer can develop a software specialized for these mobile devices, and not uh, and rather than trying to port it on or from an existing application. The usability يعني في اليوزر اكسبيرينس لانه الديفلوبرز نعم المطورين الاجهزه المطورين السوفت وير البرامج الان يطورون البرامج directly on the mobile devices، فما يحتاجون انهم ياخذون اللي هو البرنامج الاساسي المخصص للديسكتوب devices ويحولونه الى برنامج خاص للموبايل ديفايسز، على طول يبرمجونه للاستخدام الخاص للموبايل ديفايسز. The usability, the most recent mobile devices, they have operating systems which allow the radiologist to select the screen size and also the resolution which is compatible with his or her preferences and interpretation needs. The availability, so with mobile technology or maximum in mobile technology, we will have the radiologist available all the time for answering any immediate question, which will save the money and the time also.